welcome to this explainer. Today, we're demystifying a seriously essential component for anyone who repairs vintage tech or builds audio circuits. I'm talking about the 2SC2073. It's a classic silicon NPN power transistor. Whether you're trying to fix up an old CRT television or breathe some life back into a vintage audio amp, you're almost definitely going to cross paths with this little piece of silicon. So we're going to break down its specs, figure out exactly how it ticks, and most importantly, show you how to replace it without accidentally blowing up your circuit board.
Okay, let's map out our journey today. We'll meet the 2SC2073, check out its pinout and physical anatomy, look at how the transistor actually works, explore some common real-world applications, and finally, go through the ultimate replacement guide.
Section 1. Meet the 2SC2073. Understanding the core specifications.
The big takeaway here is that we're dealing with a medium-power, high-voltage component, and it's designed for both amplification and switching. It's an NPN bipolar junction transistor, packing a pretty high 150-volt maximum collector-emitter voltage, alongside a very reasonable 1.5 amp maximum collector current. It comes with that classic TO220 package, which makes it super easy to bolt onto a heatsink. Oh, and if you're building symmetrical audio stages, you'll definitely want to know that its complementary PNP partner is the 2SA940. It's also relatively fast for this class of component, with a transition frequency sitting right around 4 MHz.
Now watch out, because there's a massive trap here when it comes to power dissipation. Depending on which manufacturer's datasheet you're reading, you might see 1.5 watts, or you might see a huge jump all the way up to 25 watts. Why the massive difference? It all comes down to thermal conditions. At a basic room temperature with no help, it dissipates just 1.5 watts. But if you clamp it to a proper heatsink, it can handle up to 25 watts. The golden rule? Always use the rating from the exact manufacturer's datasheet for the specific transistor you're holding in your hand.
Moving right along to Section 2, Pinout and Physical Anatomy, Mapping the Connections. You absolutely need to memorize this standard TO220 pin configuration before you even think about firing up that soldering iron. When holding the component with the front facing you and the pins pointing straight down, reading left to right, pin 1 is your base, which is the control terminal. Pin 2, right in the middle, is the collector. That's your main current input. And pin 3 on the far right is the emitter, your main current output.
But listen up, because here is a massive warning you absolutely cannot ignore. You have to pay attention to this physical quirk. That middle collector pin is usually electrically connected directly to the metal tab on the back of the package. So, if you're mounting this onto a heatsink that it's sharing with another transistor, electrical isolation is strictly required. If you forget that, you risk a direct short circuit right across your heatsink, which will instantly ruin your day and your circuit.
All right, Section 3, how the transistor works. Understanding the flow of power.
To put it simply, think of this silicone component as an electronic valve. Because it's an NPN bipolar junction transistor, it uses a tiny electrical signal at the base to regulate a much heavier, more powerful electrical flow traveling from the collector over to the emitter.
Here's the core concept. When the base emitter junction is forward biased, usually right around 0.6 to 0.8 volts, the transistor wakes up. Supplying a small current to the base effectively opens the gate, letting that massive 150-volt, 1.5 amp potential flow from the collector to the emitter. And the actual amount of current that flows? Well, that depends heavily on your base drive, your specific circuit configuration, and the load you're trying to power.
Depending on how you manage that base current, the transistor is going to operate in one of 3 distinct modes. First up is cutoff. If the base current is essentially 0, the transistor is entirely off, 0 power flows. Second is the active region. This is where the transistor amplifies the input signal. It's basically the magic zone used in audio amplifiers and driver circuits. And finally, we have saturation. When the base is driven strongly on, the transistor acts a lot like a closed switch, which is absolutely perfect for heavy switching applications.
Which brings us to Section 4, Common Real-World Applications, where you will find the 2SC2073.
Because of that stellar 150-volt maximum rating and a really wide, safe operating area, this part totally thrives in demanding environments. You're going to find it driving the vertical deflection circuits of older CRT televisions or sitting in medium-power audio amplifier stages. Its ruggedness also makes it a massive favorite for things like inductive load drivers and voltage regulator circuits, not to mention power supplies. Finally, Section 5, the Ultimate Replacement Guide, Navigating Equivalent Parts Safely.
So, your original 2SC2073 is completely dead, and you need a replacement. Cross-reference databases are full of suggestions, right? But they are definitely not all created equal. When comparing voltage and current margins, a clear hierarchy emerges. The 2SC2038 and 2SC2344 both give you a nice 160-volt margin and are highly rated. The MJE1530 handles even higher power, but that one requires some careful checking. And then down toward the bottom of the pile, you have the 2SD772. It might be electrically similar, but it brings some real physical risks.
But let's talk about our absolute 5-star winner here, the KSC2073. If you're fixing a circuit that was originally designed around the C2073, this modern variant should absolutely be the very first replacement you look into. Assuming you get it from a reputable manufacturer, it's an NPN transistor in a similar voltage and current class, and it uses the exact same TO220 style package. Honestly, it's essentially just a modern designation of the exact same transistor family.
But you really have to be careful with those other alternatives. Just because a part like the MJE1530 comes from a higher power class does not mean it's a guaranteed physical drop-in replacement. You still have to check the pin configuration and DC current gain. And that 2SD772 we mentioned, that's a perfect example of why you shouldn't blindly trust online equivalent lists. If the physical package doesn't actually fit your board's footprint, it's completely useless to you.
As the saying goes, an equivalent does not necessarily mean a guaranteed drop-in replacement. A transistor with a higher voltage or current rating can still perform poorly or even fail if its dynamic characteristics just aren't suitable. For specialized applications like a CRT vertical output circuit or a really fine-tuned audio amp, you simply cannot pick a replacement based on voltage and current alone. You have to compare things like DC current gain, saturation voltage, and thermal characteristics. A transistor that looks super powerful on paper can fail completely if those dynamic specs don't match your circuit.
So, the next time you're bent over a workbench, elbow deep in a vintage electronics repair, and staring at a totally fried transistor, remember this explainer. Ask yourself, are you truly matching the dynamic specs of the datasheet? Or are you just rolling the dice and hoping for the best with some random online equivalence list? Always check those datasheets, verify your pins, and happy repairing.